In this lecture, we're going to talk about transition metal complexes. By the end of this lecture, you should be able to explain what is meant by the terms ligand and dative bond. You should be able to give examples of monodentate, bidentate and polydentate ligands. And you should be able to work out the coordination number of a transition metal complex and use this to determine its shape. A transition metal complex consists of a central metal ion joined to ligands by dative bonds. So for example, say our central transition metal ion is a nickel ion, okay? And it's joined by a dative bond to something called a ligand. There's a dative bond, ligand, dative bond, ligand, dative bond, ligand. Okay. So what I want to do now is explain what do we mean by the terms dative bonds and terms ligand. Okay. Dative bonds are, once formed, are identical to a normal covalent bond. What's different is the formation process. So if we think about a normal covalent bond for a second, here's a normal covalent bond formed between a hydrogen atom and a chlorine atom. And the covalent bond is represented by this shared pair of electrons. And one electron has come from the chlorine and the other electron has come from the hydrogen. The difference for dative covalent bonds is that both the electrons that make up the covalent bond come from the same atom. Let me give you an example. So let's look at the ammonium ion, NH4+. So that is produced by a NH3 molecule reacting with an H+. Okay. And a covalent bond is going to form between this nitrogen and this hydrogen. This hydrogen hasn't got any electrons, it's just a proton, so it can't donate an electron. But the nitrogen has a lone pair of electrons, a lone non-bonding pair of electrons, so it can donate both these electrons to the covalent bond. Overall, the thing will have a positive charge, and there's your dative covalent bond between the nitrogen and that hydrogen. So the only difference is the formation process. Once formed, the dative covalent bond is identical in every way to the normal covalent bond. So now that we know what a dative bond is, let's turn our attention to ligands. Now the ligand is the molecule or ion that donates the two electrons to the dative bond when forming a bond with the transition metal. So they're always donating electrons, and they are often negative ions. Chloride ions and hydroxide ions are very common ligands, or they're very often molecules with non-bonding electron pairs, like the ammonia molecule or the water molecule. So this is an example of a transition metal complex. We've got a cobalt ion here, and it's attached to 6 ligands. 5 of them are ammonia molecules and 1 of them is a water molecule. And these lines here represent covalent bonds. They're dative covalent bonds that once formed, but just like any other covalent bond. In this example here, we've got a cobalt ion as the centre, and it's attached to 4 chloride ions by dative covalent bonds. Now, the ligands are very often defined by the number of dative bonds they can form. So for example, if the ligand can only form one dative bond with the transition metal, it's known as a monodentate ligand. Examples include the water molecule, ammonia, the chloride ion, the cyanide ion, and the hydroxide ion. Now, you should remember these 5 monodentate ligands, because it's very hard to actually work out from first principles whether something will be monodentate or bidentate. Take water for example, it's got 2 non-bonding electron pairs, so it would not be unreasonable to imagine it could form 2 dative bonds, but it doesn't, it only forms 1. So just remember these 5 ligands as being monodentate. There's only one bidentate ligand that you should be aware of, and a bidentate ligand forms 2 dative bonds with a transition metal, and that is the oxalate ion. And this O- atom can form a dative bond with the transition metal, and this oxygen ion here can also form a dative bond, so it can form 2 dative bonds with the transition metal, so it's a bidentate ligand. There's also one hexadentate ligand you should be aware of, and that's the rather complicated molecule EDTA. You're not expected to remember the structure, but you should know that the EDTA molecule is hexadentate, so it forms 6 dative bonds with the transition metal complex, and we'll come across this in some of our experiments. So the circles here representing where the lone pairs come from and forming the 6 dative bonds. So 4 of them from the O- ion and 2 of them from the lone pair on the nitrogen. Now we know what a dative bond is, we know what a ligand is. The final thing we have to talk about is the coordination number of the complex. So the coordination number is the number of bonds from the ligands to the transition metal ion. And from the coordination number we can also work out the shape of the complex. Let's look at a couple of examples. Right. In this complex there are 6 bonds from the ligands to the transition metal. So the coordination number is 6. And the shape of the complex, well, we use the same rules as we did for molecules. If there's 6 lone pairs around the central ion, the shape will be octahedral. In this example, there are 4 bonds from the central metal ion to the ligands. So the coordination number is 4. And the coordination number is 4, the shape will be tetrahedral. And finally, this shows the ligand EDTA bonded to a central metal ion. And there's 1, 2, 3, 4, 5, 6 dative bonds. So once more, the coordination number is 6 and the shape will be octahedral. In some instances you may be asked to work this out just from the formula of the complex. So here is the formula for this complex. So it starts off with the transition metal ion, the cobalt, and then it tells you there's 5 NH3 groups. Now you've learnt that NH3 is monodentate, so 5 of them will give 5 bonds, and there's 1 H2O which you also have learnt is monodentate. So from that formula you can see that the coordination number is 6. Because the coordination number is 6, the shape will be octahedral. For this one, here's the formula for the complex. So here's our central cobalt ion. It's bonded to 4 chloride ions. Again, we've learnt that chloride is monodentate, so that means there's 4 dative bonds. So the coordination number is 4 and the shape is tetrahedral. And finally, the transition metal here is just shown by the symbol M, it's not any particular metal. And it's bonded to one molecule of EDTA. So you've learnt that EDTA is hexadentate. So that means there's 6 dated bonds to the transition metal ion. So the coordination number is 6 and the shape is octahedral. So by now you should be able to explain what is meant by the terms ligand and dative bond. You should be able to give examples of monodentate, bidentate and polydentate ligands, and you should be able to work out the coordination number of a transition metal complex and use this to determine its shape.